Hello everyone. We are looking at phase 3, chapter complex number, exercise 1, questions from our package. And we have reached question number 28 now. So let's look at the question. The question is that Z and W are two complex numbers whose modulus is given to us that it is less than 1. And we have to basically comment on the relationship given to us. So the way to approach such a question is also there is something argument is also given to us. So it is basically telling us that either we assume the complex number as x and y and argument is y by x. So y1 by x1 or y2 by x2. In that form it should come, or take it as r1 and theta 1. So we'll see how we can approach. But first thing first, when we are squaring a mod of a complex number, then we are going to apply the basic thing that we have learned till now. So z minus omega square. So taking the LHS expression, let's just get on with it. What is the meaning of it? So square of a complex number, mod of it. So we have to, this is nothing but z minus w into z minus w. Conjugate breaks in subtraction. So this is z into z bar, which is square, plus w into w bar, which is square of the mod, and then minus z into w minus w conjugate into z. Now this, when we just open it up, applying the simple arithmetic, now we see that this is looking like this. And this is an interesting one. I think we can get it here first thing first. So what is missing part here? If we just give it minus 2z into w. If you have given, added, subtracted it from here, so then we must add the same thing. So what has happened? This one is the square is completed. Okay, not there. So the square is completed here. Square is completed. This we can write as z minus w whole things, and then minus z into w minus w into z bar. All right. Oh, that part is also there. 2 into z bar w. So one intermediate step we have reached. Now, because argument is there, then we have to express it in polar form. So let's say z is equal to r1 cos theta 1 and z bar is phi theta 1 r1 ei minus theta 1 and w will be r2 ei theta 2 and w bar is r2 ei minus theta 2. We know that. Now let's plug it in here. So this is z bar minus w whole square minus z into, if I'm taking minus outside, so z into, so r1 r2 okay, r1 r2 e to the power I theta 1 minus theta 2. This one plus r1 r2 e to the power, now this time it is z conjugate, so minus theta 1 plus theta plus this is 2 r1 r2. Simply put it. Now this one, just open it up, this part, minus r1 r2. If we just open it up, we get cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. And this one is conjugate of this one, isn't it? If we take minus out, this is nothing but theta 1 minus theta 2. This is the conjugate of it. That means cos theta 1 minus theta 2 minus sin theta 1 minus theta 2. So that means this will go and we will be left with z1 minus omega 1 whole square, not omega w, minus 2 times r1 r2, and this is cos theta 1 minus where it is running. Again, I am taking minus 2 r1 common. So let's do that part. From here to r1 r2 there also. So it will be 1 minus cos theta 1 minus theta 2. Think trigonometry. This will break down into the submultiple angle, the half of it, and we will get z1 minus omega, why I'm calling it omega w squared, plus 2 r1 r2. This is 2 times sine square theta 1 minus theta 2 whole square. Now we have reached where now we can basically we have reached a position where now we have to go back to what is asked in the question. So this is still, LHS is still equal to this. We have to prove that LHS is less than. This was LHS, we started with LHS, this is equal to, still it is equal. We have to prove that this is less than equal to the whatever expression now we are getting. Now this one, if we look at this part, R1, R2 is less than 1. So R1 into R2 will also be less than 1. And also, if psi, for any angle or a smaller angle, sine theta is always less than theta itself. It always less than theta itself. So here also we can safely say that this whole expression is always less than whatever this is, plus 2 into 2, 4, because it is always going to be less than 4 into something, and theta 1 minus theta 2 divided by 2. And whatever this whole thing is, okay, let's write it also. Minus w whole square. Okay, so this is what it is. Now this theta 1, theta 2 is nothing but the argument of z1 plus argument of w. If I square it, so 4, 4, it will take care, and we will be left with argument of z minus argument of w. That is what theta 1 and theta 2 was. I mean, we start with something very obvious, then we just multiply everything and we reach this position. And this is where I think we have to go back to what was asked in the question. We have to now go back into the basics of trigonometry and little bit of inequality we have to involve here. That if this is 4 R1, R2 are fractions. They are fractions. They are always less than 1. So that means they will always be less than 4. And I am replacing it with something which is more. So that is why the equal to sign is now replaced with less than equal, which was what was asked in the question. All right. I believe you get the solution or you understood the question. You can go back to it and understand it yourself. So this is a good question where you have to unpack it and then you have to involve a little bit of trigonometry. And also to come to the final conclusion, you have to also go back to inequality. All right. Thank you.